Last video we learned how transactional keeps our data consistent inside a single Spring Boot application. If something fails, Spring rolls everything back. Simple, right? But modern applications do not live inside one service anymore. Let's take a simple example. A customer clicks place order. What happens next? The order service creates the order. The inventory service reserves the product. The payment service charges the customer's card. Three different services having three different databases, but one business operation. Let's see this sequence diagram to understand the problem. Everything looks perfect. Now imagine this happens. The order is successfully created, the inventory is successfully reserved, but while charging the card, the payment service fails. Let's see the result. The customer was not charged, but the order already exists. The inventory is already blocked. The system is now in an inconsistent state. So what should we do now? Can we simply add transactional annotation and roll back all three services together? The answer is no, because each service owns its own database. And that's one of the biggest challenges in microservice architecture. This problem is called the distributed transaction problem. And companies like Amazon, Netflix, and Uber do not solve it with transactional. They solve it with a pattern called Saga. And once you understand this pattern, you will never think about distributed transaction the same way again. Looking at the previous example, the solution looks obvious. Just put everything inside one transaction, something like this. Most developers expect this flow that works perfectly when everything is inside one Spring Boot application and one database. Now let's look at our microservice application. Notice something important. Every service owns its own database. Order service cannot roll back payment database. Payment service cannot roll back inventory database. There is no single transaction manager controlling all three. Now imagine this sequence. The first two services have already committed their data. There is nothing left for Spring to roll back. The data is already permanent. And this is exactly why transactional cannot solve distributed transactions. It was designed to work inside one application boundary, not across multiple independent services. The obvious answer is use a distributed transaction. Lock both databases, write to both, commit together. This is called two-phase commit. At first, this looks perfect. Either everyone commits or nobody commits. But now imagine something goes wrong. The coordinator sends the first request and suddenly the network stops responding. Now both databases are sitting there, logged, waiting for a coordinator that never responds. No new orders, no new payments. Everything starts slowing down. One slow service can block the entire business flow. That's why modern microservice system rarely use two-phase commit. But the question is, if we can't roll back, then how do companies keep their data consistent? The answer is surprisingly simple. They don't roll back. They move forward by performing compensating actions. And that's the core idea behind the Saga pattern. So if we can't roll back, what do? Let's leave software for a minute and think about a restaurant. Imagine a family of 10 people walks in and places a large order. The starter chef prepares the starter, the main course chef prepares the mains, the dessert chef prepares the desserts, and each chef work independently. Starters go out, mains go out. If a main is dropped, the kitchen does not undo the starters. It compensates, remake the dish, offer a discount, fix it forward. That is the Saga pattern. A sequence of local transactions, each independent with a defined compensation step for every action. If something fails halfway, you do not roll back the database. You run compensating actions to undo the business effect. No logs, no waiting. The system keeps moving. That is the entire mindset behind the Saga. Now that we understand the idea, the next question is, who coordinates all these steps? Do services talk directly to each other, or is there someone controlling the entire flow? And that takes us to the two Saga styles, which is choreography and orchestration. Now we understand the Saga mindset. Every action has a compensation. But another question appears: who tells the next service what to do? Who decides when inventory should reserve stock? Who tells order service to cancel the order if payment fails? There are two common approaches. The first one is choreography. In choreography, there is no central controller. Every service simply listens for events and reacts. Think of it like a relay race. One runner finishes, passes the baton, and the next runner starts. No coach is standing in the middle telling everyone what to do. Each runner simply knows their responsibility. The code is also very simple. Order service doesn't know whether inventory exists. It simply announces an order has been created. Inventory decides whether to react. Payment decides whether to react. Everything stays loosely coupled. Now let's look at another approach, orchestration. Instead of services talking to each other, we introduce one central coordinator, the Saga orchestrator. Think of it like an air traffic controller. Planes do not coordinate among themselves. Every plane talks to the control tower. The tower decides who takes off, who waits, and what happens if something goes wrong. The code becomes very explicit. The entire business flow is visible in one place. That makes debugging much easier. No matter which style you choose, one rule never changes. Every successful action must have a compensating action ready. Let's see what means in real production systems. One word you will hear constantly with Saga, that is compensating transaction. It sounds complex, but it is not. A compensating transaction is a business level undo, not a database rollback. The data was already committed. Instead, you write a new operation that reverses the business effect. Let's say payment already charged, you can issue a refund. Inventory reserved, you can release it. Order created, then cancel it. You are not erasing the history, you are writing a new chapter that corrects it. Every Saga step must be designed with the compensation from day one, not as an afterthought. Now we know there are two ways to build a Saga: choreography and orchestration. So which one should you choose? Choreography works beautifully when your services are truly independent and your teams own each one separately. The system is loosely coupled but harder to debug. The flow is spread across multiple services and event topics. Orchestration gives you one place to read the entire business flow, easier to monitor, but your orchestrator becomes a centralized dependency. One practical rule you need to remember: start with orchestration when building, move to choreography only when your teams and services are genuinely independent at scale. The Saga pattern looks clean, but there is one problem hiding inside it that teams only discover in production. Your service writes to its database, then publishes an event to Kafka. But what if the service crashes between those two steps? The database write succeeded, the Kafka event was never published. The next service in the Saga never triggered. Your data inconsistent and nobody knows. How do you guarantee a DB write and a Kafka publish happen together atomically without a distributed transaction? This is one of the most common production issues in event-driven microservices. So how do companies guarantee that a database write and a Kafka event happen together without using distributed transactions? That's exactly what we will explore in the next video, the outbox pattern.